So I think there's just 10 problems on this part of the practice test for Chapter 6. There's some messy problems, so let me just get into it. So for problems 12 and 13, there's an x and an exponent, and the problem has an equal sign. And it will always work to solve these kinds of problems by taking the log of both sides. And so that's what I'm going to do for problem 12. I'm going to take the log of both sides, and then on the left-hand side, I'm going to use the rule that allows me to take the exponent and write it in front of the log. So I'm going to rewrite the left-hand side as x times the log of 3 equals the log of 18. And then I'll just divide both sides by the log of 3. On the left-hand side, the logs of 3's are going to cancel. And on the right-hand side, if you don't have a calculator, this would be absolutely fine for an answer. The instructions say to round to 2 decimals, but if you wanted to write an answer like that, I can completely live with that. On my calculator, to figure out what that is, I would just do log of 18 divided by the log of 3. And then I'm going to have to round to 2 decimals. Since the third decimal is a 0, I'm just going to leave it at 2.63. And when I round, if I'm being careful, I usually put squiggly equal signs to mean that's a rounded answer. So both of those would be fine for problem 12. 13's the monster because both sides have x's. And because both sides have x's, it's going to take a lot of steps to do this problem. And they'll be kind of hard to follow. But the first step's not going to be so hard. I'm going to take the logarithm of both sides, just like I did when I solved problem 12. And just like I did when I solved problem 12, I'm going to rewrite each side so that the exponent is written in front of the logarithm. On the right-hand side, that exponent, because it's a binomial, needs to be in a parentheses when you throw it in front of the log. Now I'm going to clear that parentheses by multiplying out the x times the log of 2 and the minus 1 times the log of 2. And that's going to give me x log of 2 minus 1 log of 2. And I don't need to write that 1 that goes in front of the log, but I could have the 1 written in front of this logarithm here if you care to, but it's not necessary. I now need to get the x's all on the same side. And I'm going to do that by minusing x log of 2 from both sides. That's going to make the right-hand side x log of 2, x log of 3 minus x log of 2. And on the right-hand side, I cancel those out, and I'm left with the minus log of 2. Now on the left-hand side, there's a common factor of an x that I'm going to factor out. When I factor out that common factor of an x, I'm left with a log of 3 minus a log of 2. That log of 3 minus log of 2, if I leave it like that, it makes the calculator work that I'd have to do next really nasty. So I'm going to rewrite that log of 3 minus log of 2 into a single log using the rule that says if you're subtracting 2 logarithms with the same base, you can rewrite that as 1 logarithm by dividing the arguments. So this minus sign turned into that fraction, and the 3 went in the numerator, the 2 went in the denominator. And now I'm ready to solve for x. I'm going to divide both sides by the log of 3 halves. On the left-hand side, I'm going to be left with an x because those are going to cancel. And on the right-hand side, if you wrote this down, this is an absolutely correct answer. It's a non-rounded answer, which is maybe nicer than a rounded answer. When I go to use my calculator, I'm going to need some parentheses. The 2 is going to need to be in a parentheses, and the 3 halves is going to be in a parentheses. And let me get a 2 decimal answer real quickly here. So I'm going to put the negative sign and then log of 2. And then this fraction is going to turn into divide, and then the log of 3 divided by 2 for the denominator. and the second decimal is a 0. The 9 after, it's going to round it up to a 1. And for my other form of the answer, I'm going to write negative 1.7 instead of 0. That 9 is going to round the 0 up to a 1. So both of these would be completely fine answers. So you can write this, or you can write this. These are both acceptable answers. The next few problems start with logarithms, and I need to get rid of the logarithm to solve the equation. And for problem 14, what I'm going to do to rewrite the problem so it doesn't have a logarithm is I'm just going to cross the logarithm out. And in order to have the right to cross the logarithm out, I need to switch something from the left side to the right side and create an equation that has an exponent. The 3 is going to stay on the left side, and the 4 is going to move from one side to another. The x is going to move from one side to another. And you need an exponent, so the 4 is going to become the exponent of the 3. And then I can just do 3 to the 4th on my calculator if I don't have it memorized. That's going to give me 81 equal to x for my answer. And that's all there is to do for 14. I'm going to do 15 exactly the same way once I get the problem rewritten. Problem 15 has an ln, and ln is the same as log base e. So I'm going to rewrite the left-hand side with the log base e in order to do what I need to do. So now I'm going to write the problem without the log. I'm going to cross out the log. That forces me to switch the parts that aren't the base and to create an equation with an exponent. The e's not going to switch. The equal sign's going to stay where it's at. I need to have an exponent, and the 2 that moves over to the left-hand side is going to be that exponent, and the x moves over to the right-hand side. This is my answer. If you want to, you can round that to 2 decimals by, on your calculator, going second ln and then typing 2, and you get 7.389. That 8's going to round up to a 9 because the 9 bumps it up. And so the alternate choice for my answer is 7.39 is approximately x. So both completely fine answers. The instructions say to give 2 decimals, so I kind of want it, but if you don't want to give me a decimal, it's okay. 15 is yet another problem where I'm going to create an equation with an exponent. So I'm going to cross out this logarithm. I'm going to switch the 5 and the x plus 1. I'm going to leave the 2 on the left-hand side. So I'll leave the 2 on the left-hand side. I leave the equal sign between the sides. The 5 moves to the left-hand side and becomes an exponent. The x plus 1 moves to the right-hand side. And when I move it to the right-hand side, it doesn't really need to stay in the parentheses. You can do 2 to the 5th on your calculator if you don't know that it's 32. The right-hand side, you can drop the parentheses, and then I'll just solve for x by minusing 1 from both sides. And that's going to give me my answer of 31 equals to x. '17 is like one of these things is not like another. I don't know if you guys grew up watching Sesame Street, but back in the day, we used to do that. And this is one of these things that's not like another. To solve 17, because each side has a log and it's the same base, you can just drop the logarithms and set the arguments equal to each other. And when I drop the logarithms, I don't need the parentheses anymore that were in the original problem. You can only just drop logs when you have exactly that. One log equal to another log, same base, nothing outside the logarithms on either side of the equal sign. Now I just need to solve for x. I'm going to minus 3x from both sides. That's going to give me x minus 8 equals minus 1. And then I'm going to add 8 to both sides. And that's going to give me my answer. On the left-hand side, the 8's are going to cancel. I'm going to be left with my x. And on the right-hand side, the numbers have opposite signs, so I subtract them and take the sign of the larger and get positive 7. 18 is a tricky problem, and let me follow my steps. So 18 has two logarithms on the left side and a number that's not part of a logarithm on the right-hand side. Those I can't just drop the logarithms. I have to do these a little bit differently. First, I'm going to use the minus to divide rule to take this left-hand side and write it with one logarithm. Specifically, for my step 1, the left-hand side has two logarithms that have the same base that are being subtracted, and the minus to divide rule says if you have two logarithms with the same base that are being subtracted, you can make those two logarithms into one logarithm if you divide the arguments, and that's what I've done there. Now I'm going to get rid of the logarithm by creating an equation with an exponent. That's what my step 2 says to do. Let's get rid of these logarithms. And the 2 is going to stay on the left-hand side. The equal sign is going to stay where it's at. The 1 is going to move to the left-hand side and become an exponent. The fraction is going to move to the right-hand side. That's what step 2 says to do. Step 3 says make each side a fraction and solve by cross-multiplying. This left-hand side is really just 2, because 2 to the first power is 2. And I'm going to rewrite that 2 as a fraction, because 2 over 1 is equal to 2, which is equal to 2 to the first. And having each side written as a fraction is going to make it so I can solve by cross-multiplying. So I've rewritten the left-hand side to make it so I can cross-multiply down and cross-multiply up. When I cross-multiply down, I get 2 times x minus 1. When I cross-multiply up, I get 1 times x plus 2. That's going to give me 2x minus 2 equals 1x plus 2. And now I'm going to minus 1x from both sides. That's going to give me 2x minus 1x is x, or 1x, minus 2 equals to 2. And then I'm going to plus 2 from both sides. On the left-hand side, the 2's are going to cancel and leave me the x, and on the right-hand side, I'm going to get a 4. My answer to 18 is x equal to 4. So this problem isn't as hard as it looks like it should be. It really isn't that bad. And if I don't make an algebra mistake for this problem, I don't have to check my answers. So I won't, just to save some time, and it's kind of confusing to show the step checking. Problem 19, I gave myself a hint to say be sure to check for extraneous solutions. This is the one problem on the test where you can do perfect algebra and get a solution that doesn't actually work in the original problem. So let me go through this and see what happens. The reason is this ugly plus between the logarithms. It's going to cause me to factor. It's going to cause me to have two solutions. And a lot of times these logarithmic problems only have one solution, even if the algebra produces two. So step 1, use the plus to times rule to rewrite the left-hand side as one logarithm. So step 1 says to do this. Rewrite the left-hand side as a log base 2 of x plus 2 times x minus 2 equals to 5. Step 2 says the FOIL. So I'm going to FOIL this x plus 2 times x plus 2, x plus 2 times x minus 2. My firsts are going to be x times x, which is x squared. My outers are x times minus 2, which is minus 2x. My inners are positive 2 times x, which is positive 2x. My lasts are positive 2 times negative 2, which is negative 4. After I FOIL the outers and the inners, these 2x's and minus 2x's are going to cancel. And I'll be able to rewrite this problem as the log base 2 of x squared minus 4 equals to 5. That's kind of done with step 2. Step 3 I'm not going to be able to fit so well anymore, but I'm going to try to. I'm going to scratch out the logarithm and switch the x squared minus 4 and the 5. So scratch out the logarithm, switch the x squared minus 4 and the 5, and get 2 on the left-hand side. The 5 becomes an exponent. The x squared minus 4 doesn't really need to be in the parentheses anymore, but I can leave it in the parentheses. I'm going to start working down here, still finishing up this step 3. 2 to the 5th is 32, and the x squared minus 4 doesn't need to be in a parentheses. Now I'm going to go to step 4. I'm going to set it equal to 0 and solve by factoring. So I'm going to minus 32 from both sides. That's going to give me 0 equals x squared. These you're going to add the numbers because they're both negative. You get 0 equals to x squared minus 36. I'm going to factor that into x plus 6 times x minus 6 equal to 0. Now that I have it both factored and set equal to 0, I'm going to set each factor equal to 0 and solve for x. The x plus 6 equal to 0 is going to give me x equal to negative 6. The x minus 6 equal to 0 gives me x equal to positive 6. Then it says, I'm done with step 4. I set equal to 0, I solve by factoring. Step 5 says check your answer. The positive answer will check, the negative answer won't check. Write the answer that checks as your answer. So eventually, I'm going to do an answer, which is my step 6. It's just going to be the positive answer. Off to the side here, I'm going to check these. So let me check the one that does check first, going right to the original problem and changing the x's to 6. So I'm going to check the x equal to 6, and I'm going to do the log base 2 of 6 plus 2 plus the log base 2 of 6 minus 2, and make sure that that equals to 5. I'm going to do this on my calculator. I'm going to do the log base 2 of 8 plus the log base 2 of 4 and make sure that equals to 5. Now I'm going to enter this on my calculator. And on my calculator, to do this left side, first logarithm, I do log of 8 divided by log of 2. Then I put my plus sign down. Second logarithm, I do log of 4 divided by log of 2. Then I hit equals, and I get 5 equal to 5, which is perfect. So that's the one that checks, and that's the one that belongs in my answer. If I do the same thing with the negative 6, meaning go to the original problem and change the x's to negative 6, I get the log base 2 of negative 6 minus 2 plus the log base 2 of negative 6 plus 2, should I say, plus the log base 2 of negative 6 minus 2. That's supposed to equal to 5. This would simplify to the log base 2 of negative 4 plus the log base 2 of negative 8 equals to 5. And logarithms of negative numbers give i's, so the left-hand side's going to have an I and the right-hand side's going to be 5, and an I can't equal to a 5. But really quickly, let me do that on my calculator. Go log of negative 4 divided by log of 2 plus log of negative 8 divided by the log of 2. And I get 5 plus 9.06i equals to 5. And that plus 9.06i makes it not check. The 5 part works fine, but the I messes it up. So the negative 6 isn't a solution. And for my answer, I'm only going to write the answer that checks. The negative 6 doesn't check because the sides don't exactly equal each other. And I'm not going to include it in my answer. Now we just have 2 word problems to get through, and we'll be done with this review. Question 20 gives me a problem about money. It says, how long will it take an initial investment of $10,000 to double? Doubling $10,000 means multiplying it by 2. So this is really asking, how long will it take an initial investment of $10,000 to grow to $20,000 if it's expected to earn 5% interest compounded continuously? Round to 1 decimal place and use this formula. So I'm going to use the formula, the future amount of money, A, equals the starting amount of money, P, times E to the interest rate, R, times T, the number of years. And into this formula, I'm going to put the values that I know. The first value that I know is $10,000, and because it's a starting amount of money, it's going to be a P. The second amount that I figured out is a future amount of money, and a future amount of money is an A. And the last number I see is a 5%, and the 5% is an interest rate, and as a decimal, I'm going to write that as 0.05. I'm going to take those values, plug them into the formula, and solve it for t and round to 1 decimal. So I'm going to get 20,000 equals 10,000 times e to the 0.05 t. To solve this problem, the first thing I'm going to do is divide both sides by 10,000. That's going to make the left side 2 and the right side e to the 0.05 t. Then I'm going to take the natural log of both sides. I'm going to leave the left-hand side the natural log of 2. And on the right-hand side, I'm going to put the exponent out in front of the natural log of e. The nice thing about the natural log of e, I go natural log and then second divide. Natural log of e is equal to 1. So on the right-hand side, I can really think of the right-hand side as 0.05 t times 1, because the natural log of e is 1. So that I can rewrite this problem as the natural log of 2 equals 0.05 t. I'm going to divide both sides by 0.05. I'm going to use a calculator and round to 1 decimal on the left-hand side. So on the left-hand side, I'm going to do the natural log of 2 divided by 0.05. And I'm going to round that to 13.9 because the 6 causes that 8 to round up to a 9. Done with the left-hand side. I should probably use squiggly equals because it's not an exact. And on the right-hand side, I cancel out the 0.05s and get the t. That's my answer. And I'm going to just put the word years next to the answer. And for my answer for this, I'm just going to say it's going to be 13.9 years for the investment to double in value. Just one more problem left, and I think it's kind of the hardest problem that we have for the rest of the semester. So problem 21 is a kind of a two-step problem, and each of the steps is kind of what I did for problem 20. It's kind of doing the solution process twice. So problem 21 says the population of a current city is expected to double in 20 years. The city currently has 5,000 residents. So doubling 5,000 residents, which is the current population, says the population of a city is expected to grow to 10,000 people in 20 years. The city currently has 5,000 residents. How long will it take to get to 30,000 residents? This is a nasty problem. And then it says, round the final answer to 2 decimals. Use the formula, the population after 2 years equals the starting population times e to the k times t number of years. Round k to 3 decimal places. So the symbols in this, the p of t is the future population, the p sub 0 is the starting population, the k is a growth rate, and we'll need to solve this using the information in the first 2 sentences, and the t is the number of years. So the first thing I'm going to do is I'm going to take the first 2 sentences and I reproduce them down here, and I'm going to use those first 2 sentences to solve for k. So the population of a city is expected to grow to 10,000 in 20 years. So into this formula, the formula p of t equals p sub 0 times e to the kt. The p of t, the left-hand side, is the future population. I'm going to put 10,000 in for it. The p sub 0 is the current population, which is going to be 5,000. I'm solving for the k, and the t is the number of years, which is 20. So on the first step, I'm going to take these 3 values, plug them into the formula. I'm going to solve for k, and I'm going to round to 3 decimals. So I'm going to write this problem as 10,000 equals 5,000 times e to the k times 20. To solve this is pretty easy. I'm going to divide both sides by 5,000. On the left side, I'm going to get 2. And on the right side, the 5,000s cancel, and I'm left with e to the k times 20, which I'm going to write as 20k as opposed to k times 20. Then I'm going to take the natural log of both sides. This is going to give me the natural log of 2 on the left side. And on the right side, I get the natural log of e to the 20k. I'm going to bring the 20k out front and make it a coefficient on the right-hand side, which is going to give me the natural log of 2 equals 20k times the natural log of e. The natural log of e is equal to 1. So this right-hand side can be thought of as the natural log of 2 equals 20k times 1. And 20k times 1 is just 20k. So this right-hand side becomes 20k times 1. And now I'm going to divide by 20 to solve for k. On the right-hand side, when I divide by 20, the 20s cancel, I'm left with the k. And on the left-hand side, because I'm asked to round k to 3 decimals, I'm going to get my calculator out and round that to 3 decimals by going the natural log of 2 divided by 20. And I get 0.0346. That 6 is going to round that 4 up to a 5. I'm going to write 0.035 equals to k. And now the only thing I've done is I've knocked out the first sentence and the second sentence. Turns out that the second sentence I'm going to need to use again to finish up the problem. This is not the answer to the question. The question is, how long will it take the city to get to 30,000 residents? Because it's asking me a how long question, I need to solve for t. But I needed to get a growth rate before I can do that solving for t. So now I'm going to move on for step 2. I'm going to use the value of k found in step 1, which is 0.035, along with this part of the problem, which is the second and the last sentence. So the city currently has 5,000 residents. How long will it take to get to 30,000 residents? I'm going to use the same formula. The P of t is going to be the future population, and in this case, the future population is going to be 30,000 people. The P sub 0 is the starting population, and still the starting population is 5,000. The k I just figured out on the last sheet as 0.035, and I'm solving for how many years. So I'm going to take those values and plug them into this formula and get myself 30,000 on the left-hand side equals 5,000 times e to the 0.035t. That's just taking the 3 values and plugging them into the formula. I'm now going to divide both sides by 5,000. On the right-hand side, 30 divided by 5 is 6. 30,000 divided by 5,000 is 6. So I can rewrite this problem as 6 equals e to the 0.035t. I'm going to take the natural log of both sides. This is going to give me the natural log of 6. And my calculator needs that to be in a parentheses. Equals 0.035t times the natural log of e. This natural log of e is equal to 1. So this is really the natural log of 6 equals 0.035t times 1, or just the natural log of 6 equals 0.035t. I'm going to divide both sides by 0.035. On the right-hand side, the 0.035s are going to cancel. I'm going to get a t. On the left-hand side, I'm going to use my calculator, and I'm going to round to 2 decimals because that's going to be my final answer. So I'm going to do the natural log of 6 divided by 0.035, and I get 51.193. That 3 in the third decimal place tells me I could leave the 9 alone, and I'm going to say 51.19 is the answer. And when I go to write my answer, I'm just going to tack the word years to this. So my answer to problem 21, it's going to take 51.19 years for that city to go from 5,000 to 30,000 people. I'm pretty sure there aren't any word problems that we do on the test for chapter 8. So So these last two word problems are just the last ones you need to do, I think, for the whole semester. That's a bit of a lie, because chapter 9, which is the last chapter we do, has word problems, but there isn't a test on chapter 9. There's just a take-home assignment. So these would be the last test questions that you have to do, rather than an assignment that chapter 9 is.